Hello again. Welcome to yet another video. In the last video, we got introduced to chemical quantities, and what we did in that video was we took some time to talk about how we can first quantify matter and then converting among units. We used apples as a lot of our examples. Then we brought it into some more familiar things such as inches and feet. And then I asked you to do some more just straightforward, simple unit conversions. But now, because we're in chemistry class, we're not too concerned with being able to convert between miles and inches and stuff like that. We're more concerned about this huge concept, even though it's very small, but very large in our hearts for chemistry, which is the mole concept. Now, counting with moles is something that is going to be super important for many of the units that are here to follow. So in this unit, our goal is to master the concept of the mole, and then we're going to be able to use it for a lot of other things moving forward here in the future. So I'm looking forward to this one, and I hope you guys enjoy. So the mole concept, counting with moles. We have this thing called the mole in chemistry, and I alluded to it it's not a rodent. It's also not a growth on your skin, but it is a quantity or a unit that we use to quantify things in chemistry. A mole of a substance is equal to 6.02 times 10 to the 23rd representative particles of that substance. Take a second to really wrap your head around, if possible, that 6.02 times 10 to the 23rd. That's a massive number. If you can imagine scientific notation, this 23 means that there are 21 zeros after this 2. That's an absolutely massive number, a number so large that most of us cannot wrap our heads around it or comprehend. So a representative particle refers to the atoms or molecules present in a substance. So essentially, when you say you have a mole of something, let's just say carbon, my favorite element. If you have a mole of carbon, what that means is you have 6.02 times 10 to the 23rd atoms of carbon. Huge number. It's an insane amount. So it makes sense that instead of us counting individual atoms until forever, it seems, it makes sense to just say a mole. And just like we say a dozen eggs or a dozen apples or a dozen roses, essentially the mole is our chemistry dozen, except for it doesn't represent 12, it represents this absolutely massive number. Now, there is a more common name for the mole, or a scientific name, I guess, and that's called Avogadro's number. Avogadro is this gentleman over here. That number is named after him because he did a lot of work involving gases and how to determine the number of molecules and atoms that are in a given amount of space. So we thank him for this wonderful 6.02 times 10 to the 23rd number, which is going to become super important in our lives in this unit. So just to kind of give you an idea of scale of how big this mole value is. If you had 1 mole of donuts, they would cover the entire Earth in a donut layer 5 miles deep. So imagine running around the track 20 times. That's how many donuts you would have surrounding the entire circumference of the Earth. It's pretty insane. Another one, if you had a mole of basketballs, you could create a planet the size of Earth. That's pretty crazy too. That's a large number of basketballs, and I know for sure Earth is not necessarily a small planet by any means, so that's a huge number of basketballs. Now here's my last one. I promise this is the last one, but maybe some of you will really enjoy this one. If you received a mole of pennies on the day you were born and spent $1 million a second until you died at 100 years old, you'd still have over 99% of that money. So have you gotten the idea that this is a large number yet? I hope so. Now, it makes sense that we're dealing with large numbers in chemistry because, well, we're dealing with very small things. And what's nice is that we don't have to use these huge numbers all the time because, well, we have this concept of the mole, which allows us to package these very small things into a more digestible way. So what's not so important is you understanding the scale of what a mole is, but how we're going to go ahead and use that. And this is something that we are going to be able to use to convert, just like we convert inches to feet, we can convert moles to atoms or atoms to moles. So I'm providing you with an example problem. Magnesium is a light metal used in the manufacture of aircraft and tools. How many moles of 1.25 times 10 to the 23rd atoms of is 1.25 times 10 to the 20th atoms of magnesium? So essentially what we're given is we're given the number of atoms of magnesium, 1.25 times 10 to the 23rd. And we want to figure out how many moles of magnesium that is. So going with our previous concepts of dimensional analysis and unit conversion, we want to start with our given. We want to start with our 1.25 times 10 to the 23rd atoms of magnesium. That's what's given to us. Now, in order for us to convert this, we're going to use that conversion factor. 1 mole equals 6.02 times 10 to the 23rd. So I'm going to set up my conversion table. That mole value was already placed on the slide. I apologize for that. But when using that conversion factor, we want to make sure that atoms are on top and bottom of each other, because remember, we're trying to cancel out these units. And if we divide by the same unit, that's going to allow for those two units to cancel. So 1 mole of magnesium is equal to 6.02 times 10 to the 23rd atoms of magnesium. And because we have those two units of atoms on opposite sides, or top and bottom of our dimensional analysis chart, that leaves us just with moles as our final unit. So we're going to be ready to go ahead and solve this. We're going to take 1.25 times 10 to the 23rd, and we are going to divide that by 6.02 times 10 to the 23rd. And when you do that, you plug that into your calculator, what you're going to find out is that we have 0.208 moles of magnesium. So we have less than a full mole of magnesium, but this is good information to know in the case that we need to run an experiment that requires this amount of magnesium, or we need this much magnesium to produce something like a aircraft or a tool to fix that aircraft. So although we're changing the conversion factors, now we're using moles and atoms instead of more familiar units like pounds, ounces, grams, feet, inches, meters, centimeters. We have these units that are now capable of being used in the same way as our more familiar units, and we can go ahead and solve any type of question that is being asked of us. So I want you to try to utilize these same concepts to complete the 5 practice problems that are located on page 3 of the packet, or on the practice that I've gone ahead and provided for you on the weekly preview. This is something that is super important for us to understand, to be able to understand many of the other things coming our way this unit. So we're going to spend some extra time on this, making sure we're comfortable with it, but we are going to sprinkle a little bit more into it as well. So I hope that this video finds you well. Feel free to reach out to me, email me, contact me in any way you need, so that way I can provide you with the support that you need. But I'm going to leave you with that. I look forward to seeing you guys, and we will see you soon. Peace.